In today's video, I'm going to talk about engine design for the 355. This is be part 2. We're going to talk about the camshaft. A question came up on part 1 is how do I decide about the camshaft? Now, this is a little premature because I don't have the cylinder heads yet. I did talk to the customer. I have a set of aluminum bare castings coming. That way we can load the hardware in that we want into the head. Of course, I will flow check them and check the cross-sectional area to make sure that they do what I want. Now, standard small block Chevy, so it shouldn't be too hard. Remember, our goal is about 220 CFM. He wants 400 horsepower around it. So that should be fairly straightforward. The head we ordered out is an aluminum 202. I'll need to check cross-sectional area, but most small blocks have a cross-section area in the neighborhood of 2 inches, and I can always dress it a little bit if it needs to be, if I need to get it up just a bit, to make sure that I can support the 220 flow. Now, 220 with a 100% use of the flow is 457.8 horsepower. Plus, remember, this is 10 to 1, so I'd gain a little bit more, and that's a bonus. For the most part, when I design an engine, I try and overshoot a little bit because, like I've said before, the goal is 400. If I do a 390 horsepower motor, the customer's a little grumpy. If you do a 420 horsepower motor, they're happy. And so I always try and overshoot a little bit to make sure that I hit my goal without compromising what the engine's going to do. So looking at that, to hit my 400, if I use a Z of 9, remember the camshaft is based, the horsepower is based on the closing point. So if I use a Z of 0.9, that brings it down to 412 horsepower from that 220 CFM that I'm hoping to have. Now, I may have to adjust these numbers a little bit depending on what the head actually flows when I get it here and what the cross-section is. But for the moment, let's just say it's idealistic. It flows the number I need it to flow. It has the cross-section I need. So we have 220. That makes us 412. With 10 to 1 compression, that added another 6%. That makes it like a 436 horsepower motor. And so I should be able to hit my 400 even if I'm a little bit lower than the idealistic number. So if we're looking at the camshaft, the question is, what do we do? What do we need for numbers? What am I looking for when I do this? Well, the first number I look at is the closing point. That's the Z. And to hit 0.9, and I know this drawn one isn't quite right, but it's basically 20 degrees. Now, remember, that's 20 degrees at 10% valve lift. That's a valve lift, in this case, a 202 valve, so a valve lift of about 200, and that's the point I'm at. Now, he wants to run a flat tappet. This is old school, trying to keep it basic, trying to keep the budget somewhat low. That's part of the reason we found budget aluminum heads, which of course are going to be aluminum, are going to be Chinese castings. But the 20 is not the actual number we're using here. Because it's flat tappet, I have to add 25 to that. And that'll give me the number at 50. And so at 50, I'm looking at a closing point of 45 degrees. Okay? And that's where I start. Because that's what I need to hit the number I'm going to go to. Now, we can talk about lobe center here in a second, but to get back to lobe center, we'll have to do a little bit of basic math. Now, it's fairly simple. You're just doing 45 degrees, and I want to get back to TDC, so that's 180, and we just add those together, and so that's 225, okay? That's the amount of degrees from TDC to my closing point based on 050 tappet lift cam duration, okay? So then we have to decide what lobe center we want. Now, remember, overlap will affect the low end power, the power down here. And so this is a street rod. We're basically talking a 5,000 RPM engine from the last video. That puts the peak torque at like 1,500 or so, less than that. So we're talking 3,500 peak torque. Technically, it's going to operate from about 2,000, well, probably more like 2,500 to 5,000 is really the basic power band. Trying to get it so that you can run like a 2,500 stall converter, you know, a little bit of gear in the back, you know, runs nice. And that's kind of the engine we're looking at. So I do have to worry about overlap a little bit. Now, we've talked about lobe center before, and that's kind of your hit. And there is no idealistic lobe center. There is what you can deal with. Because as you tighten up this lobe center, now remember, our fill point up here at 75 degrees is one of our important points. So as we close up that lobe center, we can gain more and more hit because we get more and more fill. And so that will help us, but that will also create more overlap and will push where we're making power at a decent level up. You will come in, the torque curve will come in kind of low and then start peaking up. So I've got to be a little bit careful about that. Now, some companies like Camshaft just choose 110 lobe center and call it good. They don't worry about anything else. That makes it easier for them, and it was easier for them to design cams. That doesn't necessarily mean that that's correct. And you can't really say that there is an ideal lobe center, because technically the ideal lobe center is going to be a weight tight lobe center. You know, in the case of a small block here, if you're really after, you know, the most power, I mean, you're probably talking something that's down at, you know, 102, 104. But that's going to be a little tight for what we're doing, and that's going to mess up some of the drivability. So I've got to be a little more realistic. Now, if I wanted to be very friendly and maybe not make quite so much torque, I could go up to like 112, and that would widen it and lower the overlap. So in the case of this is kind of a street rod. Needs to be reasonable, have some decent hit. Now remember, we're only 355. If it was a bigger engine, 408, 421, something that was larger, I could get away with more camshaft because the cubic inches would carry more power. And so I also have to be a little careful because my displacement isn't that high. So let's say we want to put this on 108. And that's probably a pretty reasonable number. 108 will give us some hit. It's tight enough, we still have a pretty good fill, but it's not going to generate a whole lot of overlap. And so if we take our 225, remember from here to here is 225. If we take out our 108, which is this, we find that we have 117, okay? So 117 is from here to here and from here to here. So now that we have a lobe center and we have half of our duration, remember this is half, this is from here to here. The first thing I can do is figure out this number because I know I'm on 108. So if I take out 108 from that, that gives me 9 degrees. you know. And so this opening point is going to be 9 degrees. So we're looking at an opening of 9, a lobe center of 108, and a closing point of 45. Now this is all at 50,000 step. So the duration is just going to be twice this. So if we just double this, you know, 7, 7 is 14, area 1, 3, okay? We just figured out what we need is a 234 duration, 234 on 108, okay? So that's our basic induction cycle, and that's how I go about figuring it out. Now, this number would change a little bit if I move this down to like 112. That would move this over, lower the overlap, and make it friendlier down here. Now, it may cost us some horsepower, because remember, our fill at 75 is important. And really, if you want more hit, you'd probably be putting this on like a 104 or 105 lobe center, but that's going to increase your overlap, and then you're really going to need, you know, maybe 3,500 stall, at least a 3,000 stall converter, in order to make it stay well behaved in how you're driving it. And so that's some of the decisions you need to make. So we have a 234 cam. So let's talk about the exhaust side, because that's the other half. Now, we've talked about this before, and you need to crunch the exhaust side a little bit. Now, I am worried about overlap. I do not want to push overlap, and I know that's a personal choice. And Richard Holder says it's a lot, in that camshaft selection is a bit of a personal choice, because how much overlap you can deal with, how much bad behavior you can deal with, is up to you. Are you okay with more stall, more gear, maybe fighting it a little bit in traffic, but it sounds badass and that's what you want it to do? Then you can certainly push the issue a little more than I am here. I'm trying to compromise and find a nice in-between where it's making the power that it should, and it's fairly well behaved. And if he wants more sound, I could pump in a little more exhaust duration. Or I could look at like the Thumper series that has this kind of duration on the intake and let that deal with the exhaust side in order to get that sound I'm looking for. But in general, a camshaft like this, we need at least 10 degrees more duration on the exhaust side. So we're looking at 234 and probably 244, okay? So if we're on a 108, okay? All we have to do is divide this. This is 122, and then take out the 108, okay? So that gives us 14. So this point right here is going to be, 14 degrees, not 15 degrees. So that's 14 degrees, okay? So now we have the overlap that we're looking at. And we're basically looking at about 23 degrees of overlap at 50. And for what I'm trying to do, that's probably about the most I want to push that and not get into having other problems caused by overlap. And yes, it's a more conservative choice, but I tend to go that way and try to make the horsepower anyway. And so that should work pretty well, but where does that put us down here? Because one of the things we got to worry about is here, well, instead of subtracting, we have 108 and half of the duration 122. You can quickly see that that comes out to 230, okay? Now, we have 180 degrees from here to here, so if we take 180 out of that, that puts us at a closing point of 50 degrees. So this is more important than this number. So is this going to be okay for where I want to do? and probably not. This is probably not quite enough blowdown. Plus, I don't like that I'm 14 degrees into the induction cycle past TDC. I would like to move that back a little bit. But we want that 108 lobe center. So what are we going to do? Well, if we keep that 108, if we keep the whole induction side the same, we're only looking at the exhaust side. So if we were to do a cam that's at +4, you know, if we want 108, we want to sit at 108. Well, if it's going to be a +4 cam, then that's going to be a 112 on this side +4. So we're looking at 234 on, not 108, but we're now looking at 112 +4, okay? That still puts us at 108. But what that does is over here. Instead of 108, we're on 112, but we're +4, okay? So that puts us on 116 on this side, okay? So we have rotated the cam over and pushed the exhaust over, okay? And if you look, that has basically affected it by 8 degrees because we're +4. We widen the lobe center. We widen the lobe center 4 degrees, but then advance the cam, okay? And so that moves this out 8 degrees. Well, that means this takes 8 degrees out. So now over here, instead of 14 degrees, we're sitting at 6, okay? And instead of 50, we're sitting at 58, okay? Now that's probably a better blowdown. Now, down here in blowdown, I do have some limits of where I go. You really got to start questioning what you're doing with the engine if you're going above, you know, about 70 degrees of blowdown. Because you are dipping, remember, your power cycle's down here, and we're dipping into that power cycle. Now, part of the reason I like this is it gives me a better blowdown. I'm not real sure what kind of exhaust he's going to run, so that will help ensure that I get a decent blowdown. It'll make it a little louder, which for a street rod is certainly preferable. It gives it much more of a sound. And I have gone from 23 degrees down to 15 degrees of overlap. And I have moved this out of my induction cycle. Remember, my exhaust cycle is really over here. And I'm not really trying to make use of overlap to generate extra power. This is just a basic 355 build. I don't need to push the overlap to try and gain just a little bit of power. Plus, it's a street rod. The likelihood of it having a tuned exhaust is pretty small. So there's just no reason to push this. Now, I need the earlier opening in order to help the fill at 75 to make the induction side work really well. And I kind of have that. Now, the other thing I have to be careful of is this is just going to be a basic hyper-eutectic piston. And a 64 cc head. So I do not have a lot of piston to valve clearance. So I can't open this way early. I can't push the intake way out here opening because that makes it more open at TDC where I have to worry about piston to valve clearance. Now actually the point's not TDC. There's a little spot just past TDC where the valve is opening faster than the piston is initially moving down. And so you have to find that little sweet spot. But that's where I have to worry about. And so this basic design is what I'm probably going to look at for a camshaft. Now, I'm not going to do that until I make sure that the head has what I need. Because if I come up for some reason, can't imagine why, maybe a little short on airflow, I could crutch it with a bit more cam. If I come up higher, say it flows 230, 234, something like that, then I could technically cut back on camshaft. But I probably wouldn't in this case. For the most part, this cam is looking pretty straightforward. Now, if you're dealing with, say, a 355 and way more flow, and you're moving the power band up. Now, one of the guys asked a question, well, what if I'm at 7? Well, remember, if you're building a 7,000 RPM engine, your peak torque is only 1,500 lower than that. Your peak torque is going to be down here around 5,000 RPM. And so you are really dealing with something that's going to need a 3,500 stall converter and some decent gear in the back in order to be somewhat drivable. You're talking about a much more difficult motor that's not necessarily friendly for driving around. Now, if you're building a race motor, it doesn't matter. I mean, you might even put in a 4,000 stall converter, get it up there, and just let it rock and roll if it's being track driven, and that's fine. But in that case, you would probably run more camshaft because you could deal with more overlap. So I could actually push this out, maybe make a little more horsepower, and push what the cam is. Start looking at a 244 cam, or maybe even heading towards a 250 cam if I'm working up there. Now, also remember to work, even with a 355 at 7,000 RPM, you need to figure your CFM demand and where that's going to put you RPM-wise to support what you're going to do. Remember, this 220 is only putting me at about 5,000 RPM. So you're talking about needing a head that's going to be closer to 300 CFM. It's going to need a larger cross-sectional area in order to support that 300 CFM to get you to 7,000 RPM. And then you can add more cam in order to try and generate more power. You will have more power because you'll have more CFM and you'll have more camshaft. So you're then talking about, a 500 horsepower motor instead of a 400 horsepower motor. But that's basically how I look at camshafts. And I know this seems like I am not being super picky about each event, and that's because camshafts are actually very subtle. The reason they're listed in cam books in 10 degree or 20 degree increments is because it takes that much. There are guys that'll try and tell you that, 2 degrees over here makes a huge difference. It really should not. You may have seen something else or there's something going on. If you go look at like Eric Weingartner's LS Camshaft Challenge, I mean, he ran, I forget what it is, 14, 16 cams, something. Well, the variation between all these cams was just a few horsepower. It wasn't huge. Camshafts are somewhat subtle. As long as you have the basic principles going, you have a fairly decent fill at that peak piston speed. You pay attention to the Z because that is your inertial ram and where you're going to make, what kind of peak power you're going to make. And then basic overlap, you need to decide, and that's really about down here. Plus, if you do fairly decent, if you open this earlier, this really helps at your peak torque. And then your exhaust side, like I said, is really down here, and some of this is about carryover. Part of the reason I'm trying to push this out a little bit is I do want the engine to be a little bit louder. I have found guys tend to like them when they have a bit more thump to them. So that is one reason, and that's just trying to make sure that the customer is happy. The other is carryover, the amount of power past peak. Now in this case, remember, our peak is going to be at like 5,000 RPM. So if I can get it to carry another 500 RPM, it's still only going to make the horsepower that the airflow says, airflow and Z. But it can carry that same power, maybe another 500 RPM past peak. So then we have an engine that's fairly decently behaved from 2,500 to 5,500. And that's a pretty good range. And that's one of the things I'm kind of known for, is making sure that it has a little wider range. And part of that is because I try and spread the lobe center. Now, this is important. Do not forget about this. This is why we advance the cam. And there are times I have advanced the cam 8, 10 degrees. You know, I have twisted that puppy around because I wanted that low number there. The problem with the low number here, if you're trying to do a Z, especially a big Z, is that starts adding more and more duration. And so sometimes I don't have that ability to do. If I really have an engine that maybe has no valve relief and a small chamber, and so I have no piston to valve clearance, I may have to put this on that 112 and not advance it in order to pull this back and allow it to be okay. So sometimes you don't have a choice on what you're actually running. And up here is a lot of times about making it mechanically sound. And this lobe center is really about hit. Like I said, even on the big caddy, I mean, we're talking 500 cubic inch motor. We have pushed this all the way down to 99 degrees. And that's because it didn't have a real good fill going at the 74, 75 degrees. And so by lowering the lobe center, I got a better fill. Now, if we had a badass head up here, if we had something that was like 330, 340 CFM, we're talking a pretty big head for a small block. On a 355, we're talking about a lot more RPM. Well, we're also saying that we'll have more airflow just because the head's bigger at the 75 point. So I could go to, because we're going to be up in RPM, I could go to a much bigger cam, say 256, but put it on like a 112 or something, really push the Z down here, and try and make more power across the power band. And like I said, these are some of the decisions you need to make when you're looking at a camshaft. Now, once I have the basic design that I'm looking at, you know, in this case, we're talking 234, 244 on a 112, hopefully ground in with +4, but I can always do it on the chain if I have to. That's now the cam that I'm looking for. Now, the other piece we have to talk about is lift. And we didn't start with that. Maybe we should have. Because to hit that 220, I need the head. I need to know, do I have 220 and 500? Maybe not. Probably going to be like 550 lift. So to hit that 220, I'm guessing I need 550 lift. So now I have a duration, a lobe center, and a target lift. Now, like I said, I am not going to even look at what my choices of available cams are until I test that head and know that I'm sitting okay. Because I have a responsibility to hit the target that he wants, which is why I do what I do with the number. But that's there to explain to the gentleman that asked about how I go about looking at camshaft. And that's how I'm looking at it. The first choice is I peg what I need to make the horsepower I want. That's set. Once I have that set, I can start looking at what I can get away with and how much lobe center I can pull in and where I'm going to put the exhaust. So that's how I do it, and I hope that answers the question. I know this isn't a terribly long video, but this one is Engine Design 355 camshaft. So that's how we go about looking at camshafts. Don't get too picky. Really, if this was 232, 236, somewhere in there, you are going to get about the same results. A couple of degrees in a camshaft should not really make a big difference. Now, lift might. If you look at enough data, you will see that if you get more aggressive, if the head has enough flow and you push that lift up, say we were to do roller, I could do the same cam and roller, probably be at 600 lift. If the head supported it, I could then probably pull off more horsepower, because flow is horsepower. But that will also push the RPM up by gaining more flow. Then instead of looking at 5,000, I might be looking at 5,500. And that's some of the things you need to look at. Your flow is your RPM. Your Z is how well you're going to make use of that flow. And those need to be set. Your fill is your hit and your power down here. Your exhaust is your carryover. And I don't worry about this event a whole lot on an engine that I'm not doing a tuned exhaust. I just try my best to pull it back and not let it impact the motor. So that's how I go about it, and that's mostly about trying to make the engine flexible and well behaved. We are not, in this case, we are certainly not building a race engine. We are building an engine for a street rod. And you need to pay attention to what it is you're actually building, and not just go, well, I want, the Max Z, and I don't care if it's 8,500 RPM, we'll just deal with it. It's not your best choice. So that's how it goes. I know this was a bit rambly. I just kind of did it off the cuff to answer the question, and I hope that helps you. Again, put things in the comments. I try my best to answer most of the comments, but you also have to remember I have 2 Facebook groups that I deal with for Cadillac engines. So I've got 10,000 guys asking questions on a fairly regular basis. And so I get busy answering questions. I try my best to do all of them in the morning. So I wish you luck on your projects. That's how I do it. And I hope things go well for you. Bye.